Welcome back to Bhagaskara Labs, where we turn complex cloud setups into clear, hands-on tutorials. Today's video cuts straight to a challenge many AWS engineers face. Two EC2 instances sit quietly inside your private VPC, but how do you connect them securely? No public IP, no bastion host, no fuss, just pure private networking. Luckily, Amazon gives us a smarter tool, EC2 Instance Connect Endpoint, paired with SSH key authentication. We'll walk you through building a private point-to-point tunnel from scratch without exposing anything to the internet. Let's dive in. The first goal of this session is to establish private connectivity. Instead of exposing our EC2 instances to the internet, we'll prove that two servers inside the same VPC can talk to each other safely over private IPs. Next, we'll leverage the VPC endpoint, specifically the EC2 Instance Connect Endpoint. This is Amazon's modern way of letting us connect without relying on public IPs, bastion hosts, or VPN tunnels. It keeps our architecture lean and secure. We'll also showcase key-based authentication. By generating an SSH key on one instance and sharing only the public portion, we'll unlock a secure and passwordless login experience to the second instance. Along the way, we'll follow a hands-on workflow, step by step, from building the VPC to spinning up instances to distributing keys. Nothing theoretical, everything practical. And finally, the educational goal. By the end of this walkthrough, you won't just know the how, you'll deeply understand the why. You'll see why private connectivity, endpoints, and key-based authentication matter when designing secure AWS environments.
One of the biggest benefits of this approach is that there's no public exposure. Your EC2 instances never need a public IP, meaning they remain invisible from the internet. It also eliminates the need for bastion hosts. No extra servers, no extra costs, and no additional attack surface. This workflow is secured by design. AWS Instance Connect Endpoint ensures traffic stays private, and SSH keys guarantee only authorized users can log in. By relying on key-based authentication, we remove the weaknesses of password access, making connections both safer and smoother. It's also a scalable approach. Whether you're managing two EC2s or hundreds, the same pattern applies without complexity. And finally, it aligns with compliance and best practices. Following least privilege principles and secure access models makes audits easier and infrastructure stronger.
Now that we understand the goal and benefits, let's walk through the workflow step by step. Step 1. We'll create a VPC, our own private network inside AWS. This sets the foundation for secure communication. Step 2. We'll add a subnet and route table, carving out IP ranges and ensuring traffic knows where to flow. Step 3. We'll launch two EC2 instances inside that VPC, representing our point-to-point connection. Instance A as the client, Instance B as the server. Step 4. We'll create a VPC endpoint. This is the gateway that allows us to connect to the instances securely without touching the public internet. Step 5. We'll connect to both instances through the console using EC2 Instance Connect, verifying private access works as expected. Step 6. On Instance A, we'll generate an SSH key pair, creating a private key for authentication and a public key to share. And finally, step 7. We'll copy the public key to instance B and then test the SSH connection. If everything works, instance A will be able to log into instance B using private connectivity and key-based authentication. Every secure network begins with a foundation, and in AWS, that foundation is the VPC, Virtual Private Cloud. Think of it as your own private data center inside the cloud, completely isolated from others. For this walkthrough, we'll create a brand new VPC dedicated to our experiment. By giving it its own CIDR block, we're defining the IP address range that all of our resources will use. This step ensures that both of our EC2 instances live in the same controlled environment, where traffic can flow privately without ever leaving AWS's backbone. Let's start by building that foundation, creating the VPC itself.
Now that we've built our VPC, it's just an empty container. To make it useful, we need to divide it into smaller, manageable pieces. That's where subnets come in. A subnet is like carving out a neighborhood inside your city of IP addresses. Each subnet lives in a specific availability zone, giving us both organization and resilience. But creating a subnet isn't enough. We also need a route table, the traffic map that tells our instances how to communicate within the VPC. Without it, the servers would be like houses with no roads leading in or out. So in this step, we'll design our first subnet and attach it to a custom route table, laying the pathways for secure communication inside our private network.
With our VPC and subnet in place, it's time to bring our network to life by launching 2 EC2 instances. The first instance will act as our jump host, the client that initiates SSH connections. The second instance will be our target server, the machine we want to reach securely. Both servers will sit inside the private subnet, meaning they'll never receive public IP addresses. This ensures they remain invisible from the outside world, shielded by design. To control traffic, we'll use a single security group shared between them. By allowing SSH only from within the VPC CIDR range, we're making sure that connections can happen privately, but no one from the internet can sneak in. Outbound traffic, on the other hand, remains open for flexibility. This step essentially builds the 2 endpoints of our secure communication channel, ready to be connected in the next phases. So far, we've launched our EC2 instances inside a private subnet. But here's the challenge. With no public IPs, we can't reach them directly. This is where the EC2 Instance Connect Endpoint comes in. Think of it as a private doorway that AWS gives us into our VPC. Instead of exposing our servers to the internet, the endpoint allows us to connect securely over their private IP addresses. By attaching this endpoint to the same subnet and security group as our EC2 instances, we're ensuring traffic flows privately without ever touching the outside world. In this step, we'll set up the endpoint and make sure it's available, unlocking a secure path to both of our instances.
Now that our VPC endpoint is ready, it's time to prove it works. We'll start by connecting to instance A, our jump host, but notice something different. This time, we're not using a public IP because it doesn't have one. Instead, we'll connect through the Instance Connect Endpoint, telling AWS to use the private IP address as our entry point. This step is a milestone. It shows that our private connectivity is alive. No public internet, no bastion host, just a clean, direct link inside the VPC. And to make sure everything is consistent, we'll repeat the process with instance B. If we can connect to both machines over private IPs, then our foundation is fully working and ready for the next step, key-based authentication.
We verified that both instances are reachable privately. Now, instead of using passwords, we'll set up a key-based authentication system. This starts on instance A, our jump host. Here, we'll generate a brand new SSH key pair. The private key will stay safely on instance A, while the public key will later be shared with instance B. Think of it as creating a lock and key system. The private key is the secret key you carry, and the public key is the lock you install on the other machine. Once generated, we'll display the public key. Copy the full line beginning with SSH or SA and get it ready to paste into Instance B. This will allow Instance A to log in securely without needing any passwords.
We now have the final piece of the puzzle, our public key from Instance A. The next step is to place that key inside Instance B, so it knows to trust connections coming from A. On Instance B, we'll move into the .ssh directory and edit the authorized keys file. Think of this file as a guest list. Only the keys inside it are allowed to enter. By pasting Instance A's public key here, we're granting it access. Once saved, we return to Instance A and attempt an SSH connection directly into Instance B using its private IP. If everything works correctly, the login will succeed without needing a password. This is the moment where all the pieces, VPC, private connectivity, endpoint, and key authentication, come together into a secure, functional workflow.
And there we have it, a complete walkthrough of how to establish a secure SSH connection between two EC2 instances using only private connectivity, VPC endpoints, and key-based authentication. We started from scratch, building the VPC, subnet, and route table, then launching our instances, creating the endpoint, and finally proving secure access with SSH keys. This workflow not only keeps your infrastructure private and safe, but also follows AWS best practices for security and compliance. If this tutorial helped you understand EC2 networking better, don't forget to like this video, drop a comment if you have any questions, and subscribe to Bhagaskara Labs for more hands-on cloud and infrastructure guides. Thank you for watching, and I'll see you in the next deep dive.